Suppose you want to prove to your friend that you have two different Smeeskies, but you don't want to reveal which ones they are. How could you do this?
Well, here's one approach. Start by hiding your Smeeskies under two identical opaque containers. Without you looking, your friend can choose to switch or not switch the containers. Then, without revealing to your friend the Smeeskies in the containers, you can check and tell your friend if they switch the containers or not. Since you know the Smeeskies are different, this should be an easy task. Of course, from your friend's perspective, you had a 50% chance of guessing if the containers were switched or not. Skeptical. So you repeat the process again. Now you have a 25% chance of guessing correctly. And turns out, if you repeat this process just 10 times, the chance of you guessing each turn correctly is reduced to 1 over 2 to the 10th power, or 0.001%. Not so skeptical anymore. We just convinced your friend that you had different Smeeskies using a zero-knowledge proof, or ZKP for short. Zero knowledge, meaning the verifier learns nothing other than the fact that the statement you are trying to prove is true, and proof, for being a method to prove the authenticity of a statement.
So what qualifies what we did as a ZKP? Well, 1. It had completeness, meaning if the statement was true, which in this case it was, an honest prover, you, could convince an honest verifier, your friend, of this fact. 2. It has soundness, meaning if the statement is false, the prover could not convince the verifier that the statement is true, except for a very small probability. As mentioned earlier, although you only have a 0.001% chance of correctly guessing 10 cycles, this is still a non-zero number, meaning ZKPs are non-deterministic and therefore different from traditional mathematical proofs. And finally, 3. It was zero knowledge, meaning the verifier learned nothing about the statement besides that it was true. Your friend doesn't know which Smeeskies you have, only that they're different. Perhaps proving you have different Smeeskies to your friend is trivial, but because zero knowledge is particularly useful for privacy, ZKPs have a lot of interesting applications in the real world. Cryptocurrencies like Zcash utilize ZKPs to reveal that a transaction occurred without revealing the sender, receiver, or the transaction amount. Signal, a popular secure messaging app, also utilizes ZKPs to manage group memberships by allowing users to prove they have the credentials needed to join or modify a group without revealing those credentials. ZKPs can even be used for nuclear disarmament verification. Supposedly, if country A got into a nuclear disarmament agreement with country B, ZKPs could be used to verify that country B truly reduced their nuclear arsenals without revealing sensitive information about them to country A, and vice versa. So whether you want to prove to your friends that you have different Smeeskies or want to verify nuclear disarmament, ZKPs can be an awesome tool to help you achieve this.